has been a very famous KM method. So referring to these two people. So this is a very important subject, of course. What is spontaneous electric braking? Because it applies to all physical systems. But rather, I want not to talk about this anytime it is open to us, so we may discuss it some other time. Instead, let us talk about two more up-to-date subjects. That means that concern all of us. So one is about the dark matter, and the other one about Nobel Prize in 2012. Nobel, who got it, how got it, why got it. Okay, I think these are more up to date. So first of all, the dark matter is, of course, a well-known subject for a long time. Let me give you some simple examples from our solar system that we know well. So we have our sun. This is our star that shines in our solar system. Now, it goes on. Planets, of course, they are not aligned, you know, but just to show the relative distances, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, Pluto, goes on. Now, the problem is, if we consider that each one is rotating about the sun, they are not rotating with the same velocity. This is a well-known fact, because the period of, let us say, Mercury, or Venus, or Earth, are not same. Okay. So this is well known for many years, last 200 and more years. It is known that the velocity, so this is, we call them the orbital velocities, or approximately, if you consider that they are making circular orbits, you can call it circular velocity, because we know very well about the circular motion. So, if you have an attractive center, then you have tangential velocity, so the force exactly balances or satisfied by the central gravitational field of the object. So that is how they rotate roughly, I say, because the orbits are not exactly circular, but it is elliptical. So, now, one thing, if it is only mass that affects the rotational speeds, then naturally we would expect that each one rotates with the same speed, but it is not. So this is something that we know. Now let us come to another well-known experimental part of astrophysics, cosmology. roughly, let us make a sketch of our Milky Way galaxy. So, at the center, it is believed that there is a supermassive black hole. So, I can give its exact mass for our information. So, this is a black hole, and roughly, I want to sketch something of a spiral galaxy. It is not exactly this one. Definitely there are distortions. But roughly, this picture is, when you look at any pictures, this is what you will see. Okay? So this is called a spiral galaxy. So exactly Milky Way is something like that. So our solar system, let us say it is somewhere not very outside, not very inside. I think it is somewhere here. This is the solar system. So we are all here now. Now, at the center, there is a black hole. We believe there are good evidences. Now, the mass of that black hole is, so if I denote its mass by m, so m is about 4×10⁶ mass of the sun. So that notation means mass of sun, our sun. So the mass of that black hole is 4 million times the mass of sun is sitting here. So this is the reason why these are not running away. Otherwise, if there were no so big mass at the center, nothing would keep the. So that is so big. But of course, if we return to other galaxies, like the galaxy that is nearest to us, our Milky Way, is Andromeda. So let us take another one. Here, Andromeda. At the center of this one, there is a black hole of 140 times 10⁶ mass of our sun. You see the difference? 440. But, of course, still these are not very large. When you go to some other galaxy, this is called M87. At the center of that, you have a mass which is 3 times 10⁹ mass of our sun. 4 billion mass. That is terribly much more than our Milky Way. Okay. So now, of course, we'll know more about this. Now, look what is happening in this, our spiral galaxy. If the same rules that we saw in our solar system worked, then I expect that the periods of stars appearing here at different layers also should be different. But that is not the case. This is introduced a very big problem now. It turns out that the velocity of this one, this one, this one are all same. Okay. So that means their periods are also same, unlike the solar system. Okay. Okay, but this, how can this be? Because when you go outward, you expect to have the contribution of more mass. Okay, so, but corresponding to the space that they occupy, you should expect a change in the rotational velocity. So, now it is measured that our solar system has a velocity of 240 kilometers per second. This is the velocity of our solar system with respect to the center of the galaxy. And if they did not rotate at the same speed, then this structure should be scattered. Okay? You will never have the same picture. But it seems that the picture is preserved as it is. So, now when you convert it into the mass involved, then it turns out that definitely there must be a dark matter. With the contribution of dark matter, only this structure is possible. At least there should be, you should not have this order. The order should be dispersed in time, and you should not be able to see this spiral structure. Of course, these spirals are everywhere in.
Excuse me, sir. So what is the effect of this dark matter in our solar system? Because if there is some dark matter in that picture, of course it is in our solar system as well.
It seems that the dark matter is effective at large scales. And when you look at this, it is just a spot here in this very large structure. So that is why they are concerned about the gravity at large distances must be different. It is not like at small scale. So, by the way, this distance also is measured. So I can write it down that this distance is about R 26,100 light years. So, 1 light year is equivalent to 8.5 10 to 12 kilometers. So normally, remember Newton's law. If I know, so you see, I know this speed here, tangential circular speed, I know the distance, then I use this simple formula, V squared over R, mass of our solar system completely, and solar system. This must be equal to, from Newtonian formula, you have this expression. So I cancel the mass of the solar system goes. So you have V G M over R root, this one, but this M is variable. It is not constant, you cannot take it. But in Newtonian theory, there is a rule that only inside is affecting the outside. So normally, that means, since I know this bit, that means if I shade all this region with this radius, I can apply this formula and I can find what is the big M, what is the mass involved in here. So if you do that, what you find out is that this formula does not hold true. That means something is missing. So, because here in the mass that you count is only the Newtonian mass. Okay? So, but it does not give the correct expressions. These are measured. Distance, velocity are measured. Therefore, you know what they are. The only unknown is this big M mass here. But it does not give you correct. It does not satisfy as an identity. So that is how this idea of dark matter came up. So, therefore, we are convinced that there is some other kind of matter here that contributes at distance, so that when you go to this orbit, to this orbit, or any other orbit, it will give you the same velocity, but mass each time will be different. So that is exactly what have been detected, and they are trying to discover what is this dark matter. They call it dark because it is not known exactly what it is. So the distribution of that masses, in fact, we can give exact figures like percentage in each one. It is roughly 72% of the whole mass in the universe. They call it dark energy. That is also even more mysterious, that it is even less known compared to the dark matter. Now, there are many candidates, of course, that the dark matter may be, but so far, no one knows exactly what it is. So it is one of the unsolved mysteries about this our galaxy, but it is the same idea is valid for all galaxies. By the way, this Andromeda and Milky Way, it is believed that they are coming, approaching each other, and within 5 billion years they will collide. So that will be very, very disaster, of course, so that collision of 2 galaxies will give rise, will scatter so many other things, but maybe the black holes will merge together. So only what they do simulations to give what will happen. Okay. So it will be a very, very big, disastrous event. But as I said, this is supposed to be within 5 billion years. So it is not an immediate future. Okay, so this is some figures about this Japanese made a recent experiment because many different groups are trying to know more about the dark matter. So the Japanese, the experiment that they did, they claim that the dark matter that so far is known is more even than it was thought before. So they give a figure, they say that dark matter is 20% more than estimated. So if we consider roughly 20, 75, 5, so dark matter, dark energy, and normal matter, let us say, rough figures. So what did Japanese say from their satellite experiments that they did? They estimated that this figure is more than 20%. So its weight is more. This is a recent result by the Japanese air agency. Okay. So there is, of course, a challenge here to understand what is the source. There is an invisible source here which does not appear in the Newton's formula. Because in Newton's formula only you have a mass. That is all. But if you have any other fields of any type, then it does not appear here. You have to make some more additions in order to balance this equation. Okay. So this is what they are trying, and this is the meaning of finding dark matter. It means you have to find what kind of interaction you have. Okay. Because interactions make the energy. Energy means mass. So, what are the mechanisms that make this mass or energy extra so that it is not visible, you cannot detect it, but in physics formulas, it has to show itself. So this is an open question. Therefore, I will not talk more, but of course one idea is that there are unknown, undiscovered particles. So, for example, one of them is axion, which arises in last 20, 30 years. In physics, they put such a particle as a result of some symmetry breaks in Maxwell theory. If you break that duality expression, you automatically get the axion. But you add an extra term in the Lagrangian, so the Maxwell equations become more complicated because automatically a new particle has to be taken into account, which is a scalar field, massive scalar field. So they call it axion. But as I said, this has not been discovered, so therefore it may not be even a valid argument. This is the fate of theoretical physics. You propose something, but what they say, man proposes, God disposes. So it may not be correct. When you propose something and it turns out to be anticipated or proved experimentally finally, then that becomes a reality, and this is exactly what those two people got the Nobel Prize of this year. Let me put down their names. This one is French, this is American, but this one was born in Morocco, our country. Okay. So he was educated in Morocco, North African state. And then he moved to France, and in France he got PhD and so on. So it seems that he is an Arab origin in some way. Now, before I come to that point, let me tell you a few things about this galaxy pictures. In most of the figures in nature, you see these spiral shapes. Look at seashells that you take from the sea. You see that picture exactly like a horn. Now, when you look carefully, in these spirals, what you face is you see a golden ratio, it is called, between these lengths. It is not right. So, I think they describe this by consider a straight line like this. Now, let me take this length to be x. Now I take a cut and let me label A, B, and C. So AB, let it be 1. BC, let it be x minus 1. Then this ratio, x over 1 to 1 over x minus 1, is called golden ratio. Golden ratio. Let us see here the total, and this AB is 1, so this is x minus 1, so that is 1. So ratio of these two, this one, x over 1, is ratio of this over this one. So this is called golden ratio. And it appears in many parts in nature, including plants, seashells, and so on, even in galaxies. Okay? So, if you solve what is x, this gives you a quadratic equation, x squared minus x minus 1, 0, and it has a root exactly given by 1 over 2, 1, And it appears in many, many natural formations. Okay. So, but it appears in a strange way also. In mathematics, there is a sequence or series, it is called Fibonacci series. So there also it appears in a mysterious way. So this series, if you take its division into going to infinity, an plus n over an goes exactly to 161. So naturally, it arises in this what is called Fibonacci series. What is this series? It is just one later term is the sum of two previous terms. So very easily, we can write all the terms of this Fibonacci. So 3, 5, 8, also. This is called Fibonacci series, and when the term goes on and on, the ratio, when n goes infinity, it is the same golden ratio. So, therefore, in many natural things that develop, you find this ratio. But I did not see if anyone discovered Fibonacci black holes. Because what you should do, just you will ask for the roots of this algebraic equation. So that means the horizon radius of that black hole must come out as the natural, this golden ratio. And probably there are such sequences of black holes that are derived from the golden ratio. Because if it appears in other systems, why not here also? So, now this name is coming from Filios Bonacci. That means son of these. Okay. And coincidentally, this also was born in Algeria, and another North African state. So this Fibonacci was educated also in the Arab country, Algeria. Originally, he was an Algerian. And the reason that he arrived at this Fibonacci series, he studied the nice art in mosques or carpets and other things. And he discovered this art or this Fibonacci series in this manner. So it is interesting that the Muslims cannot see, but others can see. So there are books written about these series and where they appear. But of course, the interesting thing always is that what kind of source makes this spiral formation? So that question is of course open. Definitely, it is not the Newtonian source. But we have to find what source it is that makes this. Once I remember, I was solving a rotating electromagnetic universe matrix. And I noticed that the geodesics are coming out as spirals. Okay. So I said myself that these formations of the spiral character is as a result of gravity plus electromagnetic field together. So the existence of these two long-range fields give exactly these spiral structures. Okay. So that one I had noticed some long time ago, but unfortunately this has not been considered by any other authority that to explain why we are having these. You see, in all the other galaxy formations also, you have the similar structure that it is a competition of long-range forces, namely gravitation and electromagnetism. So, two of them together may be the reason, cause of these spiral formations. And what I expect is that maybe one day, by these measurements, since we have so much sophisticated measurements, we may prove that our Milky Way galaxy fits exactly into that golden ratio. Okay, so that if I see that, I will not be surprised. Okay, now, as I said, there are books written about these golden ratio and where it appears, so if you are interested, you can consult such books. Now let me have a look at this problem. These people, they reach to the same conclusion by going opposite ways. They were studying in quantum optics. These were field of specialization, quantum optics. But here, of course, one faces the mistakes of quantum theory. I think one of the most familiar mistakes is Schrödinger's cat. So today I said to Reshad, Mr. Reshad, do you know who got Nobel Prize this year? He said, no. I said to you, two people, they solved the mystery of Schrödinger's cat, and they got Nobel Prize. He said to me, they put the cat in the box, and they opened the box, then the box, the cat is either dead or alive. Okay? So, what is the thing here? Of course, needs some expert to know the detail of what is going on here. Inside the box, you have a cat, or even you can put a person or anything. But you have a radioactive source. This must be isolated completely from outside. There is a trigger here that it decays into by radioactive source, and it gives out a poison that instantly, whether you are man or cat inside the box, you die. So, but what you don't know whether this radioactive source decays or not, because that is a probabilistic event. If we say 50% chance, then if the source decays, that man is dead. If it does not decay, he will be alive. So, the same thing for the cat. So, now to ask the question before you open the box, is the cat inside alive or dead? Okay. So, if you consider that those two states, as a quantum state, now the quantum probability is much different from classical probability. If you toss a coin, you have either head or tail. Do you have any other possibility? No. But if you toss a 1-2 coin, there are infinite possibilities. Not only head or tail. So, if alpha is 0 or pi over 2, then you have one of these states. So you can call this dead or alive. Dead cat and alive cat. You parameterize it like this. But you have a continuous parameter alpha, which is ranging from 0 to 2. So there is infinite of possibility. For example, with the choice of alpha, I can say, the man inside the box is 20% dead, 80% alive. Or other way. So you have infinite of possibility here. This is the result of the superposition principle in quantum mechanics. And it is the most mysterious thing that all the possibilities are involved. So that is the thing that nobody could understand so far. Can you isolate now? The important question here is, before I open the box, because when I open it, it will collapse either dead or alive. It will come to the end points. Okay? When I open it. But before I open it, can I know exactly in which state is my system inside the box? Can you say, or can you predict the quantum state involved inside the box? And in certain sense, this amounts to the solving of the Schrödinger's cat paradox. Okay? Because it is not possible to find, just toss the coin. I've never seen anything other than head and tail. It means now what these people showed, I can see also something between. No head, no tail, something as a quantum state, and it becomes a reality. This is what they have shown. it is a very, very advanced level of physics here that nobody, I think, can understand. But in order to make things understand, that is why they are referring to the Schrödinger's cat. So the animal lovers objected to that. Why you are putting cats inside box and you are killing them? Okay, so you can put inside someone else or other than an animal. Okay, so you can do whatever, but the problem is the idea. Of course, the problem is not so simple. It is the most important or most difficult point is to isolate a quantum state. See, as I said, alpha different than 0 and pi over 2, and isolate that quantum state in some way without collapsing to the endpoints. Okay. So, as I said, this is what these people have done. Now, they asked one man who first time succeeded in teleporting a photon. Teleportation. This means something will be carried to some other place, very far distance. So this is what is known as teleportation. It is one of the most important challenges in physics today. There are many people working on teleporting something, but so far they could not teleport anything except a few photons. And I remember the person who made the first teleportation, he said, I have been working for 20 years in the laboratory, in the high optic quantum laboratory, and I succeeded only to teleport one photon. Can you imagine? Now, one photon must be 2 photons, 3 photons, a bunch of them, and then more difficult. You have to go to teleport a virus, smallest Li object, virus, which has only some nanometer extension. So they are working on this, of course. They are trying to teleport something other than only photons. Because only photon means information. If you can dissolve any physical system into information completely, then you can teleport information. Because you have only photons, you can teleport them, and then after teleport, you convert the photons again into physical system. This is the idea in teleportation. So this is what they are trying to do, but unfortunately, there are very, very serious problems. How to dissolve a physical being into complete information. So there, we face with the subject of information. What is information? So this is going to be one of the most important subjects in theoretical physics. Okay. So it is believed that by some eminent scholars, they say matter is weighted by information. Because when you go to lower and lower scales these are valid only. So therefore, it means that you can construct matter from information. So that is why they are trying to use photons, teleportation, and then dissolving matter into photons or information. So this will be probably one of the most fantastic research subjects in coming decades. Okay? So the whole thing lies in understanding the quantum theory. So quantum theory holds the key of so many doors that opens to great secrets. So just to recall, Richard Feynman had said, no one understands quantum mechanics. True, something happens, but how does it happen? Why does it happen like that? We cannot know. Okay. So we are trying to give an explanation. So what these people did, they isolated single quantum states, okay, without collapsing into the endpoints. So, in terms of the Schrödinger's cat, which has been a mystery for 80 years, when it was first suggested, everyone was asking about it. Some of the philosophers, they said, this is nonsense. There is no solution to such a problem. So it seems that there is a solution, but that solution is not easy to reach to. So the contribution of these two people maybe helps to understand better large-scale quantum effects. Because quantum was taught only to be at micro scale, at the atomic level, inside atom molecules. But when you go to outward, of course, you cannot talk. When you are talking about the galaxy, there is no quantum theory. Classical is enough, because it is so large a scale. So you do not know where the border is between classical and quantum. So there are hundreds of articles written, where does classical start, where the quantum ends, where is the limit? So that is also not well defined. Okay? But so much sophisticated and advanced physics shows that there are some way to understand the secrets. Okay? But it takes your whole life. It is not so easy, some hanky-panky, and get the prize. Okay, what they say, there is no free lunch. Every lunch or dinner has a price. You have to pay. Now, how did they show? They used Rydberg atoms, artificial atoms. They did not use natural atoms. So, Rydberg atom, this is its name, Rydberg atoms. They are man-made atoms. It is 1,000 times size of the normal atoms. But they were produced in the laboratory. So, even you can produce anti-Rydberg atoms. What does that mean? Look at hydrogen atoms. You have a proton and you have an electron. This is what we call hydrogen atom. Okay. There is hydrogen or anti-hydrogen atom. Also, I can define, now this is proton, this is electron. Now if I choose an anti-proton at the center with negative charge, and you have a positor here going around, this is called anti-hydrogen. These are all constructed in the laboratory for the last 20 years. And Rydberg atom is also some type of atom, but it is man-made in the laboratory. And the important thing is it has a size larger, 1,000 larger than normal atoms. So they use that atoms, Rydberg atoms, in order to get what they wanted. And ultimately, they succeeded in isolating quantum states without collapsing it. Okay, so that means I can toss the coin and I can have a state of 20% head, 80% tail. This is fantastic. But the physics behind, as I said, takes your whole life. Easy. In a few words, just to, if it was so easy, there were many people to do it 50 years ago. Okay? So this is shortly what I can tell today. So let me put a full stop at this point. Always try to run after mysterious things. The thing that you will say must be interesting. If you say anything that every stupid knows, that is not interesting. You see? So this thing is very interesting. That is why they earned the Nobel Prize. Okay? So you have to, everyone whose mind works must run after interesting things, mysterious things that no one knows. You see? This is physics. Okay? So physics is interesting in this sense, that it runs after these unknown things. Whether you discover something or not, of course, it is not obvious in the beginning. You may not discover anything. That is also okay. But at least they say, you run after it. And they said one aunt started to go to Mecca to become Haji, El-Hajj. So another aunt told her, where are you going? I am going to Mecca to be Haji. Your life, that is not enough to reach there for an aunt. What the aunt said, at least I die in the way. The important thing is the intention. If you have a good intention, then, and you struggle